assignment that has a PDF in it, and the PDF has a 9.1, but pause. What's the title of their 9.1? Infinite Series. That's not our 9.1. So this is the AB textbook. This is on CalcChat, so you guys can go ahead and access your, I think it's exactly. No. It's not their book. It's not the blue book. Hold on. It's the black book. What? It's okay.
It's a black book?
Yeah, it was the one that we had for BC originally before I changed to the Finney one that you guys have. So this is the 10th edition, and you guys know on CalcChat it's by picture, right? So you're looking for the calculus book, and you're looking for calculus of a single variable. It's 10th edition. I think it might actually be up there somewhere. Maybe it's not. But it's the black one by Larson and Edwards. So it's not our Finney one. Our Finney one is the normal one that we use. It is a Larson one. It's just not the same National Geographic one. The blue one is last year. It's a bit thinner, so you guys can probably imagine it's a bit more of a college textbook than the AP edition. The one you had last year was an AP edition. This is just a regular calculus book, okay? So this is the one. I'll have it up here. You guys can see it every day. Take a picture of it on the way out. But that means you can't use the other book for homework. Oh, wait. These are in your Google Classroom announcements. You just pull it up, right? The PDF, the homework assignment. Nice. Okay. So anyway, this is where you're going to find homework for each of the homework assignments for. Now, do you guys see the title of this? Oh, maybe you can't. I call it Chapter 9 OT because it is the chapter. You're going to be seeing 9.1, 9.2, 9.3, etc., etc., etc. You're going to be seeing Chapter 9 as you go through. And I think I've just given you, have I given you all of it? Yeah, I've given you all of it. It's the same PDF. Just scroll to 9.2 or 9.3. Just keep an eye on the page numbers. Don't just start. Ooh, guys, listen. Hold on. What's the first page that you see? 592. What's the first page of homework? Why did I do that? Because we've already covered sequences, not series. This is their homework coverage of sequences, not series. Okay? We're starting in section 9.2 because we've already done our book's version of this, but I might refer back to every now and then or have a review problem every now and then that goes back to 9.1. So you have those if you need it. But we're basically we're starting here in 9.2. Make sense? Don't do the wrong thing for Google Classroom. Check the pages. Tonight's homework is 9.2. Oh, look at the back board. What's the section we're supposed to be covering today? 9.2. There is a quiz on Friday on 9.1 to 9.3, but we're not doing 9.0. Oh, we already did. Our 9.1 is sufficient coverage of sequences, but you also have a couple review homeworks, I think, review homework problems coming. That you look back at their 9.1 also. Now, here's the weird thing for notes. We're going to actually call this, I'm going to do the section titles the exact same as the book that you're going to be using for homework. So I don't want you to be confused. You're just going to have OT on everything because it's other textbook. That's just why I was Old Testament note or other textbook. But I technically call this our Chapter 10 intro chapter. I technically call this our Chapter 10 intro chapter as far as we are getting ready for Chapter 10, but our book goes way too fast. I want to slow us down. And most other books, as you can tell, have a whole chapter before the Chapter 10 that we're trying to get to. They just kind of condense, change things a little bit along the way. Some of our chapters they made separate, whereas other books would have made together. So anyway, we're doing Chapter 9 OT, other textbook. We're starting in Section 2 because we already have a sequences section, not series. And technically, I think I wrote it up there. Practically every new section in this chapter is going to have 1 to 2 new convergence/divergence tests. So we are getting into infinite series, aka not bounded, plus ... with an infinite upper bound. Series because they're being added. A series is the sum of a sequence. So even if a sequence converges or diverges, are asking ourselves now the question, ooh, but what about the sum of the sequence? Not the terms, but the addition of what happens as I add another, and another, and another, and another. But yes, you do have CalChat again if you locate the correct book. In Google Classroom, you will have PDFs of all of the Chapter 9 OT every single time, so you have to scroll to the correct section to find what you're supposed to be doing. Otherwise, it's pretty much same old, same old. Just don't try to use your book for these homework problems, or else it's going to be very sad. Now, if I were you, something that I would highlight, just as a concept, not so much as an endeavor card, we're going to have plenty of endeavor cards, but what is an infinite series? If basically the rest of the year, basically, we have like a polar parametric vectors thingamabob coming in chapter, 11 or something like that. We do have a little bit at the end that is not infinite series. But the bulk of our second semester is infinite series. If that's the bulk, okay, so what is it? Infinite series are. I said is because it's the limit. Is defined as the limit of a sequence of partial sums. Not of the sequence that's being added, but of the sequence of partial sums. So what if we add the first two? What happens if we add the first three? What happens if we add the first four? What happens if we add the first five? What happens if we add the first n? And all of that is building up to what happens if we add them all. Is the sum converging or is the sum diverging? The big question we're trying to answer. Is the sum converging? Is the sum diverging? So if you're thinking infinite series, a series with, or that is an infinite sum of terms of a sequence. We can't just go to infinity, so we approach infinity. But to approach infinity, we do it not with the terms themselves, but with the partial sums. Because we have to think about what's going on as we add. We have to think about what's going on as we add. Are they stabilizing? Are they converging or no? Not they as in the terms, they as in the partial sums. But as I was saying before, every time we cover a new section, we're covering 1 to 2. I don't think we ever do 3 tests that only apply to certain sequences. It's rare that a single test can apply to every single one. And so please pay attention as we're doing examples, etc. I'm going to be giving you hints and tricks because in a certain homework section, you're only going to be facing the series for which the test applies. But when you get to the end of the chapter or section 9.1 to 9.3 for our quiz, or the end of 9.1 to 9.5 for the test, you're just going to be given a big old jumbled set of series that you're going to have to figure out what test does it go to. Now, have we done this before? Kind of. If I give you a random function and say take a derivative, don't you have to go back to your catalog of all the different derivative rules and figure out which one or ones apply, right? Or integrals, same thing. I gave you an integral, and you have to go back to your prior knowledge of all these different rules, which one applies. I want you to be thinking in that sort of vein with these. In a homework, all of the sigmas, all of the series are going to be similar in some way, shape, or form. Or maybe if there's 2 tests, similar in 2 different ways. But as we add on another test, all of a sudden, okay, it could be jumbled. Some might be still solved, determined to be convergent or divergent based on an old test, or maybe by the new test. So it's going to get harder and harder as we cover each new section, because now there are more and more possibilities when given an infinite series as to what to do or how to go or what direction to head. So we've already talked about earlier. I'm not sure if you guys necessarily need to put this because we already put this. This was back when I taught this book and I covered this chapter before covering what we've already covered. So just a quick reminder of some of these you're going to be a bit baffled by. at some point in time during the next couple 2 to 3 weeks. If you do want to be able to explore the sequence of the terms, aka the infinite sum, the infinite series, you can go to your calculator and you can at least play with them in the calculator, going to the graph or the table to predict what's going on. And so I put up here just an example of a couple different ones. We cannot put the infinite series in our calculator, but what we can do is put from 1 to n, and then we can go to our table and say, what if n is 10, or n is 50, or n is 100, or n is 1,000, or n is 10,000? And our calculator sometimes is going to take so much time to do that because it's doing so much math. It's finding all the different terms, it's adding them all together, etc. So sometimes our operating system basically will get bogged down if we try to go too high. But this can kind of give you an idea of, oh my goodness, I think it's converging to negative 1/3. Can I figure that out on my own? But then there are other ones where you're going to be like, I don't know, I went to 100 and maybe it's stabilizing, but I don't see it near as clearly as up here. So there is the idea that we can use our calculator to explore, but we got to get better than that. So to get better than that, let's start talking about our tests. In this section, 2 tests, geoseries and nth term. Geoseries is technically a convergence and divergence test. For very special sequences, for very special series, aka only for geometric ones, I can decide whether it's convergent or divergent based on pre-calc. An infinite geometric series, which we talked about in pre-calc, is just a little bit jumping the gun. We can talk about whether that geometric series is going to converge or diverge based on basically the pre-calc. If it's not a geometric series, this test doesn't apply, so it's not going to really help or hurt. It's just going to be irrelevant. But if it's a geoseries, we got it. Huh? K equals 1. Yeah, it's like the index of our sum function. So from k equals 1 to infinity of a times a is just some sort of initial times r, the common ratio, all raised to the power of k. And this is actually an old school when I first started teaching you guys limits, a sub 1 over 1 minus r, because there was a much longer, you don't have to write it. You guys can keep taking the endeavor part, sorry. But there was a much longer formula for any nth term of a geometric series. We learned this one first. But then we zeroed in on this part where the n showed up in the formula, and we said, okay, if we're going to infinity, and I introduced the limit notation, if we're going to infinity, when will this increase or decrease without bound versus when will it stabilize? And technically the book just said memorize it. But it makes sense rationally too if you start raising fractions to powers, fractions that are in between 1 and negative 1, fractions that don't even yet have a magnitude of 1. Because 1/2 cubed is 1/8, 1/2 to the 4th is 1/16, 1/2 to the all of those, even if it's 9/10, even if it's 99/100. If you keep raising them to higher and higher and higher powers, all powers raised to n where r is in between 1 and negative 1, where the magnitude is not yet 1, are going to go to 0. But that only happens, meaning this formula will only stabilize, meaning, this isn't a sub n, this is s sub n. The infinite, or I should say the nth partial sum formula. This will go to 0, and hence I'll have an answer, and hence my infinite series will stabilize, but only when magnitude of r is less than 1. But if magnitude of r is greater than or equal to 1, whether positive or negative, if it's equal to 1 or negative 1 or beyond, I'm never going to have a stabilizing. It's always going to go to infinity or negative infinity. Or possibly DNE. But long story short, I could call this divergent. And I think that's even when I first introduced the word diverge to you guys in that. As an infinite geometric series. This is something we totally talked about. And when it did stabilize, well, this whole thing goes to, the first time you guys use the arrow to say approaches, goes to 0, so then what's left? Well, a sub 1 times 1 over 1 minus r. This is one of the few, one of the very, 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 very few that you can actually determine not just whether it converges or whether it diverges based on whether the magnitude of R is less than 1 or whether the magnitude of R is greater than or equal to 1. But you can also say what it converges to. If it's convergent, I can also, and if I were you, I would strongly advise that you put that this is the sum. If it converges, we not only know that it converges, but what it converges to. That's very rare in CalcBC. We can say convergent or divergent, but it's very rare that we can actually mathematically, without using technology, figure out what it converges to, but Geo is one of the few. So if they were ever to ask for the sum of an infinite, man, we hope it's Geo because we have a formula for it. If it's not, we hope it's something else called telescoping, and if it's not, we hope they're not asking for it. Huh? Yes, go team. Endeavor number, where are we at?
14.
Yeah, it was on my list to get caught up on this weekend, but I also had to figure out a whole new algebra. I got today figured out for everyone. Go team. Not tomorrow, the next day, Anyway, I just recorded that. Anyway, so all this stuff down here. All this stuff down here is just pre-cal. It's recapping, so just remembering that Geo is when you can multiply by a common ratio. So R is our common ratio. To get from one term of the series, it's dangerous to say sequence now. Yeah, it's dangerous to say sequence now. Our series, because sequence was just saying, hey, what are the terms doing? Are the terms stabilizing? That was easy. The limit exists, the limit doesn't exist. Now it's like, oh, does the sum stabilize? But the nth partial sum, that's not something that we really need to get into our endeavor card because we're not really using nth partial. We're always going to infinity now. So the infinite sum, that's when we just need to think about the limit as n goes to infinity of s sub n, which we already talked about on the board, so I don't think I really need to write that down. It'll still be on the board, anybody else watching? It's on the board if you need it. But basically, this will either go to 0 or infinity or negative infinity. It'll only go to 0 when magnitude of r is less than 1. It'll go to one of these guys. Magnitude of r is greater than or equal to 1. Wait a minute, greater than or equal to 1. But I thought if it's 1, it just stays the same, right? Why is that a problem? Well, let's talk about some examples. Let's start with what if the sigma is not there? Let me give you a second to get it down. Let's start with what if the sigma is not there? Yes, from here on out to the end of the year, we are rarely going to finish a section in a day. It'll usually be 2 to 3. It's going to feel more like CalcBC. But then that means you need to do homework in much more of a CalcBC way as well. Hopefully how you did in CalcBC. Meaning, focus, spreading it out, doing a little bit at a time, coming with questions, and not just cheating out CalcChat.
Oh. I'm not pre-cal. Ever since the Google Classroom. Really not my fault.
Wait, Abby, did you?
Huh? No. Wait, number 3? Infinite sum? It's the one that I wrote. Girl, I don't know.
Yeah, that's what she's saying. She's
Yeah.
saying the infinite.
The limit of
Alright, we're trying to find 1, 2, 3 things. We're trying to find 3 things. Now remember, we can't do the sum if it doesn't converge. If it diverges, there is no the sum. Okay, common ratio. Who's my R? You just have to speak loud because everything right up here is fuzzy. Thanks. So, and I'm going to throw a since before that. What? She's putting words? Okay, find my common ratio. What does that common ratio tell me about the next question?
Converges.
yeah.
If there was no R, if this wasn't a geoseries, then it doesn't matter what I thought R was. It has to be a geoseries for it to work. But only geoseries have common ratios, so it's kind of redundant, I suppose. this geoseries will converge. Two. The sequence goes to 0, but the sum goes to a sub 1 over 1 minus r, 1 over 1 minus 1 half, which is 1 over 1 half, which is... I just used something. Where's your endeavor card? Where did we write or label sum? A sub 1 over 1 minus r. Who's a sub 1? The first term. Who's r? So a sub 1 is 1 over 1 minus 1 half. 1 over... The sequence goes to 0. But the series goes to that. Wait, but think about it though. Because 1 plus a half is 1.5, right? Plus a fourth is 1.75. Plus a fifth is, that's 0.2, 1.95. See what I'm doing? So even though the terms are going to 0, the sum is ever expanding but limited. Does that make sense?
Yeah.
Wait, so it's 1?
A sub 1, first term.
Okay.
Over, the formula says 1 minus r, plugged it in, which ends up being 1 over 1 half, which ends up being 2.
So is it always the case of like, usually like it says like 1 minus r sub r to the exponent of n? Is that always like the first term?
This is if we're doing like the nth partial sum. If it's an infinite, aka if it converges, that just goes to 0, so we will always have the first term over 1 minus the common ratio.
Okay.
But that's only true if it's convergent. Does that make sense?
Uh-huh.
A sub n.
Can we just watch that you do this?
Stop.
Okay, how about number 2?
R equals negative 1/3.
He's seeing the 1 to 1/3 jump, and he's asking, that only works if it's times 1/3 and then 1/3, but then he sees the negative. Yeah. Now, I'm going to add one more step just because this is great and it's good and all. But some of you, this won't be enough for you to remember this in a few sessions, and especially in like a few weeks. So we're going to add, and we're going to say this is in between.
In between.
Where does r need to be in order for a geometric series to converge? In between negative 1 to 1. So I'm saying since r is equal to this value, which is in between or which is within negative 1 to 1, oh, that's why I can say. So I'm basically just reminding myself of the test, right? This geoseries converges. And geoseries are the ones that I always know where it converges to. And it'll converge to 1 over 1 plus a third. And it's 1 over 1 minus a negative 1/3. Isn't that going to be 1 over 4/3, which is going to be 3/4?
Yeah.
We were wrong. We were wrong, silly Billy.
He's a silly Billy anymore, but I like it. Yeah.
Are they gonna like? Is this gonna be an easy test?
To some degree, but you're gonna have to go a lot faster. I just have us write out our work, so if it was an FRQ, we get to find our answer, number 1. And number 2, it makes it such a test is hopefully solid.
So we're gonna
That's
right. Let's just say these tend to show up in where you have like 2 to 3 to 4 different series in one question, and you say, oh, 1 converges, 1 and 2 converges, 1 and 2 and 3 converges, 1 and 2 and 3 and 4 converges. For the multiple choice. For the long answer. And you have some good old fill in the blank with these tests. And you need to make sure that your logic is in place. Hey, what about this one? Now we have sigmas. 1/2 is your common ratio? How do you know that?
Because I plugged in 1, right? It was 1/2.
Ooh, he started plugging in things.
Wow.
Like in sequences, how I said find the first 5 terms. Then plug in, you get 1/2, and then plug in again, and you get 1/4. And how do I know that? One's supposed to start at 1 and just keep on going, right? So I get 1/8, and then okay, I think a dot 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 is in order, right about now. So since r is equal to 1/2, which is also within our corrected boundary, right? Yes, this geoseries converges. But what does this one converge to? Would you guys have gotten 1 and not 2? Wait, why is there a 1/2 up top? The first term is 1/2, but would you have known that if you didn't try expanding? Maybe not. And if your bottom bound was a 0 instead of a 1, well, the answer would have been 2 because you would have started with a 1 plus 1 half plus 1. We did something. Number 4. You guys in your groups, we have a few minutes, no? I'm kind of tired of myself talking. You guys.
It's okay.
Figure out who you're, ooh, you have 2 examples. Who do you think your common ratio is? Do you think it means convergent or divergent? And if it's convergent, what does it converge to? Go.
5 times -1 to the nth term all over 4n fourth fraction. So 1 term is yes, Abby.
Whoa!
5 over 2.
So that's 5.
Oh.
So what do you think the common ratio is?
-5 over 16?
No,
Yeah.
+5.
So since they're
Oh,
between
yeah.
-1 and 1, does it converge eventually?
Converge.
-5. So now, what does it converge to?
Wait,
3, what's 3?
the
4
first
times 4 is
is
16.
-5
16 times 4.
over 1 minus, oh, plus 1 over 4?
No.
Yeah, we don't.
4
2, 16. 4.
Good job.
Woo! Yay!
17?
Stop using these. Wait, the answer.
So
Before.
since
So R is yours.
R
Which
equals
one equals infinity over 4 over 4, right? That becomes 4 over 4 plus 1 over 4.
Let's start with
So
multiply the 4?
you can multiply the sigma
if you turn to
or
4,
imply. Imply.
So
Yeah.
that's negative 20 over 20.
Yeah, negative 20 over
That's
20.
actually 1.
Yeah.
You guys agree with the
Yeah.
first one?
times -4.
Whoa.
If you start plugging in, the 5 just stays the whole time. You could technically be factored out of everybody. It could technically just be a 5 times a sigma if you wanted it. The 5 doesn't make a difference. The important guy is the -1/4 that's being raised to the Anyway, yeah, it's convergent. And then you take your first term over 1 minus the negative, which is 1 plus your 1/4, and then -5/4 over 5/4 is -4. We good? On number 4.
Oh, tangent.
So is it actually
No.
1 or 0?
Let's not do tangent.
What?
What? You're plugging in and you're figuring out it's 1 plus 1 plus 1 plus 1 plus 1?
Yeah.
Wait,
What?
is that diverge or converge?
Diverge.
Because you're going to be adding 1 forever. Isn't it going to be forever be getting bigger by 1? Doesn't that mean it's going to infinity? But wait a minute, why is this under the geo series? Because if you had to have a test to defend your answer, why is this geo? What are you multiplying by every time? Isn't 1 on the boundary line? Not within? This geo series diverges. There's no more you have to say. But good that your brain realizes that this does just go to infinity. Diverge. It's not stabilizing, never will. It'll always be increasing by 1. How about number 6 though? This one's interesting. You gotta figure out that this is, plugging in 1, that's an even power, which means, but then all of a sudden, 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 but then. How many guys would think that's 0 if I had just thrown it on the screen randomly at the beginning of today? geoseries diverges. Let's talk about how it diverges. Just because right now we can still kind of visualize what's going on. Soon we're going to be like this. But right now, why could or how could your brain realize this isn't infinite, but it doesn't exist?
Going back and
It keeps going back and forth. It's never going to make up its mind. It's never going to stabilize. 1 second, if you pair them, it's 0. The next second, it's 1. The next second, it's 0. The next second, it's 1. It's one of those just going back and forth and back and forth and back and forth. Never stabilizing. Could some argue 0? Sure. Could some argue 1? Sure. They're both wrong. If it's infinite, it'll be neither. If it was a finite one, oh hey, like the what was that derivative you guys were supposed to find last year? Like the 42nd, 95th, 112, 536. But it was 28. Whatever it was. It was a 20-something derivative. You're like, they expected us to take that many derivatives. No. Could they ask you for the 512th partial sum? I mean, would they? Probably not. But could they? Yeah. It's either 0 or it's 1. You figure out which one. Find a pattern and follow it. That's exactly what you should have done for the 28th derivative last year. Find a pattern and follow it. Not actually take 28 derivatives.
I had to should have taken
Well, maybe it was in more. Correct. You had it. Anyway, there's one more test. Ooh, we get to see both tests in one day. That's exciting. Usually it's just one test. But there's 2 tests. But geoseries, I mean, technically, come on, it's pretty tough, right? But it only works for geoseries. Guess what this test only works for? Divergence.
Wait, what?
Geoseries only works for geoseries. Divergence test only works to prove divergence. And here's the dangerous, dangerous, dangerous test that if you don't make a note of today, you could totally fail Friday's quiz. Oh, it could be bad.
So.
Some people love to use this test to tell them 2 things instead of just one. This test can only tell you if something is divergent, and that's it. So if it's not divergent, we don't know what it is. What I mean is, if this test doesn't prove divergence, it can't prove convergence. It can prove we don't know from this test, we need another test. This test, like the geoseries, doesn't work on everything or everyone. And the hard part about this test is it says look to the sequence. The hard part about this test is it says look to the sequence. Yes, believe it or not, I already forgot what endeavor we're on, even though I just wrote it down.
Is it 15?
Thank you. Now, some of you might be like, I don't get it. It says nth term and there are k's. Okay, if you don't like it, then just make them n's. It doesn't really matter. Either way, you can call them n's, you can call them k's, you can call them whatever they want. Nth term just means keep going, right? To the nth term. Look to the nth term. What is the nth term doing? Is the nth term stabilizing? That's sequence. Oh, so far you've forgotten? Look to the sequence. Not series. Remember, we were supposed to, for convergence of sequences, always be remembering that anytime I said the word sequence, you were supposed to fill in
Not series.
because convergence and divergence of sequences,
Not series.
say just, oh, what's the limit of the terms? But the limit of the series, oh,
Not sequences.
so much more complicated. Except this test says, well, if I work, I guess I'm easy. If I work, which one is it working?
No.
This is the conclusion it can make. This is the we know nothing. Like literally, I want you to write we know nothing. If you try to do this test and you get 0, I want you to always write you know nothing. I don't mean you know nothing about life or nothing about anything, but about this problem. If you get the limit of the sequence not to be 0, you know nothing. If you get the limit to be anything but 0, you know everything. Wait, anything but 0? Like infinity? Uh-huh. Like D and E? Uh-huh. Like a number? Uh-huh. The only way that a series
Not sequences.
Can converge is if its limit of, the limit of its terms is 0. But I just said that's the only way it could converge. Did I say it did converge? No. So if you just get stuck in that section 9.1, sequences,
Not
it's
series.
about like, oh, take the limit and whatever. If the limit's a number, I'm done. Right now, if the limit's a number that's not 0, you're done. You can say the infinite series diverges. But if you get the limit to be 0, your brain's going to be like, converge! But it's not convergent. We know nothing. We know nothing. Because it may or may not.
I know that it but
Which means, we know it may, but we know it also may not. So,
if it's anything natural, so like 1.
yeah. 1 half, -2.
Then it's just
Infinity, all of them diverge. All of them, the infinite series diverges.
Would it actually be like a multiple?
Because of what we just saw. Hold on, because of what we just saw. Hold on, because of what we just saw.
Bro.
Listen. What were these sequences? What were the terms converging to? Wait a minute. What were they the whole time? 1, not 0. Oh, it's divergent. We could have also done the nth term test. What's the limit of the terms? I don't know. 1 and -1. It doesn't exist. Okay, perfect. It's not 0. It diverges. Now, this is dangerous. This is dangerous. This is dangerous. But you're going to have to see it yourself, and some of you are going to make some mistakes because of it. What are the terms going to? Oh, it converges. This time. What is it going to? What are the terms going to? 0. Oh, it converges. This time. Let me show you one real quick. Ready? Ready? This guy. Convergent or divergent? It's easy, right? Most brains would say convergent. It's called the simple harmonic series. We're going to see that it's divergent. Kind of has to do with that whole 1 over x and the Gabriel's horn thingamabob. But here's the hard part. What are the terms doing? They're going to 0. But may or may not converge. Just because the terms are going to 0 just means it has a possibility to. This one actually diverges, and this one proves. This one, there are many, but this one proves we can't just say limit of the terms are 0, we're good. We're not. We just might be good. But the nice thing is with the nth term test is, well, if the limit's not 0, we're definitely not good. Okay, cool. So, some of these you're going to know nothing, and some of these you're going to know everything. There's no in between for the divergence. It's either nothing or it's everything. Everything, you're done, make your conclusion. Nothing, oh well, got to go figure out something else. And right now we only have 2 tests. So if it's not either one of them, oh well, I guess we wait. This one, what's the limit? As n goes to infinity of n squared. Not 0. And as n goes to infinity of n squared is not 0. Therefore, what can I say?
Divergence.
Yeah, we can say the series. I'm going to take off the infinite. The series diverges by, now, before I was saying geoseries, so it was obvious it was the geoseries test. But this one, okay, hold on, we got to attach a test to our rationale. By nth term. Is that good? Cool. How about this one? The limit. I'm not going to put the since unless it actually shows me something. Limit as n goes to infinity of x to the n all over ln of n. It will only equal 0 if the who wins. Stronger. Ln of n or x to the n. We could do a L'Hopital's. No, this is not 0. So you guys will need to show it in order to have your proof be perfect. But what are we going to do if it says the limit is 0 of the sequence? We're going to say we know nothing. We're going to say WKN for me. But you know nothing. You have to move on. Bye guys. See you later, Gators. We'll practice this a little bit more tomorrow before starting on 9.